Hi, Amit Sharma. Welcome you all to Mathematical Coaching Center. In today's class, we'll do force and pressure. By the end of this video, you'll be learning what is force, pressure, and moment of force means. SI unit of force and moment of force. At last, we'll solve some important numerical problem. So without further delay, let's start today's class. Now here comes force and pressure. So what is force? So force is push and pull action resulting in the change of motion and direction. So what does this mean is that suppose I have an object, you can see there is a box and two boys are pushing this. So force is either push or pull. So what happens that the body was at rest initially. When you apply the force, what happened? The body is in motion, so you can see it's in motion and it's in particular direction. So force is nothing, it's a push and pull which results the change in motion and direction. If I'll apply the force from this side, this direction, what will happen? The body will move in the other direction. Similarly, what happens is that suppose a car is moving and you are applying a brake. So when you'll apply the brake, the car was in motion, now it will come in rest. So force, got it? So force is a push or pull action results in change in motion and direction. So similarly, force, pressure. So pressure is physical force per unit area. So you can see pressure is nothing, it's force upon area. So what is the relation between force and pressure? So pressure equals to force upon area. You can see in this figure, so we have an object, so we are applying the force in this. And how much area is this? This is my area. So whatever is will be received in this area, so it's called as pressure. So pressure is nothing, it's force upon area. So here you can see the force acting over a smaller area. A smaller area will have the more pressure. You can try with your pencil. Pencil, the sharpened one, if you put on your palm, what happens that the sharpened one will have the more pressure. But if you put the eraser one, it will have the less pressure. Why? Because the smaller area will have the more pressure and the more area will have the lesser pressure. So now we have moment of force in physics. So moment of force, you can see we have a range. So we are applying a force here to open this knot. And what you have here is distance. So the force and distance is called as moment of force. So moment of force is nothing, it's a product of force and perpendicular distance. So in exam you can write, what do you mean by moment of force? Moment of force is defined as the product of force and perpendicular distance. So we have here the moment of force depends on two factors. Number one is your force and number two is your perpendicular distance. So if this spanner is smaller in size, suppose I have to apply the force this position. So distance will be less, that means you have to apply more force. That means lesser the distance, more the force. Now you can see in the spanner, distance is more, that means your force will be less. So the moment of force depends on two factors. Number one is your force and number two is your perpendicular distance from the axis of rotation. Now we have SI unit of force. SI unit of force is, you know that it's your Newton. And what is the SI unit of moment of force? So moment of force formula is force into distance. So force unit is your Newton and the distance unit is your meter. So therefore, so moment of force SI unit is Newton meter. And whether it is scalar or vector quantity, as you know, scalar quantity means having only magnitude. Vector quantity means having both magnitude and direction. So as you know that force is a vector quantity because it has magnitude also, it has direction also. Since force is vector quantity, moment of force is also a vector quantity. So in this example you can see we are taking out this nail by an hammer. So force is this side and the more the distance, so what happens, the force will be lesser. You can try this experiment at home. Open your door and now try to close this door by putting your hand at this position D1 and at this position D2. Okay, so this is your hinges are there. Now if you'll apply the force here, what happens is that easily at D1, easily you can close the door. because more the distance, lesser the force. But if you apply the force at T2 position, in this position, what happens is that you have to apply the more force. Now let's solve some numerical problem. Now here we have a numerical problem on moment of force. As you can see, we have the question. The hinge of a door is at a distance of 40 centimeter from the point of application of force. If the force is 20 Newton is applied, what is the magnitude of force? So what they had given us, distance they had given us, and they had given us the force. So what is the magnitude? So we'll always, numerical problem, we'll write solution given. Force is how much? 20 Newton. And what they are given, distance is how much? 40 centimeter, and I have written in meter because we have to change in SI unit. Okay, so why? Because 1 meter equals to 100 centimeter. Okay, similarly what you have, 40 centimeter. To change in meter, we have to divide by 40 divided by 100. So 0 will get cancelled. When 0 will cancel, point will come. So I got 0.4 meter. Okay, so hope so you are clear. Now what you are finding is that magnitude of moment of force. So moment of force formula is force into distance. So force is how much? 20 Newton, and distance is how much? 0.4 meter. Actually what they had given is that we have a door, okay, like this. The hinges means the kabja, the hinges is as the end here. What is the distance from here? Distance is 40 centimeter. So they are given 40 centimeter. You are applying the force here. You are applying the force here. And how much force you are applying? 20 Newton. And you are finding the moment of force. You are finding the moment of force. Moment of force is force into perpendicular distance. Hope so you are clear now. Now what happen is that now this is your 20 Newton into 4. 4 I can change like this. 4 upon this. When I remove the point, 10 will come here. 0 will get cancelled. So meter is there. So what will be? 2 4s are 8 Newton meter. So this is my moment of force, and always you have to write the unit. Okay, hope so you are clear with this. Now we have another question. What they have asked in this: what is the perpendicular distance between the force and the turning point? So we have to find the perpendicular distance. Force they had given 25 Newton, produces the moment of force they had given 12.5 Newton meter. So always in numerical we'll write solution given. So what they are given, force 25 Newton. Newton is the unit of force, SI unit of force. Next what they are given, moment of force. Moment of force is how much? 12.5 Newton meter. So Newton meter is the unit of moment of force. What you have to find, perpendicular distance. We write this way, okay, perpendicular distance. So perpendicular, you know that perpendicular means, suppose a line is there, a point, this is called as perpendicular. Perpendicular means always it has to be a 90 degree. Now we know that moment of force formula is force into perpendicular distance. Hope so you are clear with this. Now what we are finding is that we are finding the perpendicular distance. So just we'll put the value. So what is the value of moment of force? I got 12.5 Newton meter equals to force we have, how much we have? 25 Newton into perpendicular distance. Okay, now you can see this is in multiplication sign. So multiplication, when you go, that's it will be divide. So or I can write 125. So Newton meter. Now you can see here is point is there. When I'll remove the point, what will come? 10 will come down. Hope so you're clear. Now this multiply, when it go, that's it will be divide. So 25, what you have? Newton equals to perpendicular distance. Okay, now I think so it will get cancelled by how much? You can see the Newton get cancelled. Now 5 5s are 25, this 5 2s are 10, 5 5s are 25. Yeah, now it will go by 5 1s are 5, 5 5s are 25. So what I got? Now you can see here is 0 is there. So I got 5 upon 10. So 5 upon 10, what can I write? When I'll cancel, what will be? The point will jump inside, yeah. So 0, when I'll cancel, the point will jump inside here. So equals to what I got? 0.5. What is the unit? Meter equals to perpendicular distance. So therefore I got, perpendicular distance equals to perpendicular distance equals to how much you have? 0.5 meter. 0.5 meter is your how much is your, if you change in centimeter, as you know 1 meter equals to how much? 100 centimeter. Yeah, so 0.5 means it will be 0.5 meter. I can write 5 upon 10 into 100 centimeters. 0 will can cancel, 5 tens are 50 centimeter. So it's nothing, it's your 50 centimeter. So this question carries 3 marks. Okay, hope so you are clear with this. And please like, share and subscribe to our channel.